Okay, so we're looking at question 234, palindrome linked list. Given the head of a singly linked list, return true if it's a palindrome. So, example 1 and example 2. Constraints are that the number of nodes in the list is in the range 1 to 10 to the power 5, and then the nodes itself, like the values ranges from 0 to 9. And there's like a follow-up or like a hint kind of thing where basically they ask if it's possible to, like the hint is to do it in linear time and constant space. So I did attempt this question like just a little while ago because I already made one recording, and the thing is like it wasn't optimal, so I am doing a re-recording of this walkthrough. Yep, so let's get started. So let's talk through the thought process of this first. My first thought is to kind of draw out a linked list that has an odd number of nodes, so we know how to handle like both cases of even nodes linked list and odd noded linked list. Yeah, so here we are. And okay, so basically to find out if a linked list is a palindrome or not, we can use the fast slow pointer approach, where we use the slow pointer to kind of figure out where the middle of the linked list is. And then as we traverse through the linked list, we would want to reverse the first half of the linked list and compare that reversed first half linked list to the second half. And if they are the same, we can consider them a palindrome. In the case of this odd numbered linked list, basically we can just ignore whatever value is in the middle and compare the reverse first half and the second half. Okay, so let's see how the fast slow pointer approach will work in this question. So we have, let's use a different color. Blue maybe? Okay, so I'll use blue to mark the fast pointer and then red to mark the slow pointer. Okay, so they start off at the first node, head node, and then the first step, well, the fast pointer will step 2 times over to here, and then the slow one will just go 1, right? Node number 2. Okay, this is 1 step. Basically, it terminates the whole stepping thing terminates when fast pointer lands on a null node, or dot next is none, right? So now it's still fine, so we keep going. Blue again. 1, 2. Okay, now we stop here because we are on the last node and the next one is a none value. So don't forget to step the red one as well. Okay. And then now let's look at example 1. Blue, and then red, slow pointer. Okay, first step, we go 1, 2 here. And then second step, we go, oh no, and then for the slow pointer, first step, we come here. And then we can still keep going, right? Because it's the dot next there's another node in the dot next position. So we go 1, 2, blue node, we land on a none. value. Let me just draw a line in the middle to, maybe purple, to kind of demarcate the division between these two examples. So, and then step 2, our slope pointer will land here. And then we use this, just draw a line in the middle where we have to compare the first half and the second half. So, okay, so we can see how in the first example, our slope pointer is already on the second half, right? Like on this position. Whereas for our example on the right, our slope pointer is in the middle, which is not what we want because, well, like we would want it to ideally be on here, this 4th node, because we don't want to compare 3, 2, 1 null with 2, 1 null. We want to compare 2, 1 null with 2, 1 null. Yeah, okay. So, yeah. So we have to make sure that we put in a conditional where if the fast pointer lands on a node, then we have to increment the slope pointer by 1 step. Okay, and then to explain how we would do the reversal, we would basically come up with a dummy node and then call it prev pointer. Start off here, and then on step 1, we basically link this node to this prev, and then step 2, we do this. So as you can see, like just nice at the end of 2 steps, we have our reversed linked list over here to compare it with this half. Same for the other side. If we have a prev, let's just call it P. And then do this, and we do it step 1. Step 2, we have this 2, 1 none, and then to compare with this 2, 1 none. Okay, with this diagram drawn out, let's get started. So first up is to initialize the pointers. So P head. And then remember we have to have like a dummy prev node, and which we initialize it to none. And now we can start our fast slow pointer traversal. While fast p dot next is not equal fast p not none, and fast p next not equals none. Basically we want to do fast p step by 2, and then do the reversal, right? So we use a temp placeholder to kind of like hold the .next node so it doesn't get lost. And then we basically point the slow piece .next to the prev, and then we can shift prev to the slow piece position, the old slow piece position, and then finally we can shift slow p to the temp position. Yep. Okay. Next what? Okay, so once this finishes, we would want to remember to step the slow pointer up 1 step if fast p is odd. which is the case when fast P is on a node that is not none, is on a not none, is not none. So if fast P, let's refer to the diagram again. Yeah, okay. Slow P dot next. Okay, so finally we have another while loop to check if the first half linked list, which is marked by pref, and the second half linked list, which is now marked by slow P, are equal. Yeah, so pref and slow P and slow P. If the moment the values don't match up, aren't equal, we return false. If not, then we just keep going. Okay. And finally, return true if everything passes. So let's try this. Okay, great. So thanks for watching the video.